We would like to welcome our next speaker from Porsche, live here in the studio. He's already joined us here on stage. The next presentation is titled FDX, a new data format for functional data exchange. And our next speaker, Dirk Ruschmeier, who I have right here next to me, is responsible at Porsche for PDM data management for CAE and simulation and for PDM data exchange. He brings along 25 years experience in virtual development in the automotive industry and over 10 years of experience in data management and data exchange in CAE and simulation, and was also chairman of the VDA Working Group for Functional Data Exchange, FDX, with its foundation in 2015 until 2018. As always, we would like to encourage you to ask questions using the chat function. You can start using that right now, actually, as soon as we begin with our presentation. And I would like to say, Dirk, the stage is yours. Thank you for joining us.
Thank you, Jasmine.
Thank you
very much. Good afternoon from my side. Yes, I speak to you today as a representative of the Working Group for Functional Data Exchange, FDX. This is a joint working group from the prostep ivip association and the VDA, the German Association of the Automotive Industry. And before I go into some of the concepts and status of our working group, I would like to give you some background on why we started the working group in the first place. Now, in the last decades, a lot of emphasis has been put on how to build and use physical prototypes. And in the recent years, much more emphasis has also been put on how to build and use virtual prototypes. So virtual prototypes come in different forms and shapes. In order to be able to use this information and build and use these prototypes in the different disciplines and departments, you have to have different types of data. In comparison to what the physical prototypes have, they have their components, the physical components, and in the virtual prototypes you have the data. We heard that sometime before today. So in our recent years, we have come to the conclusion that we need to strengthen this process in the same way that we optimized the physical prototype process. Now, the different types of data that we need for the different types of virtual prototypes come in different shapes and forms, and some of them are listed here below. Geometrical data, obviously one of the obvious ones, but my focus today will be on the functional data, and all of these data types have in common that they must meet certain data requirements. Some of them are listed here, and I will elaborate on some of them a little later on. So after looking at this in general, I would like to come to the functional data. Functional data is maybe not so easily defined. Let me specify what we mean as functional data in our context. The physical components of the car are represented by different parts, and so the geometrical data represents the shapes and forms of these parts, but functional data represents the characteristic properties of these mostly mechanical components. Here are some listed. We have them in chassis engineering, we have them in powertrain engineering, we have them in body and electrical. And as the components come from our suppliers around the world, functional data also comes from these suppliers all around the world, and we have them coming into the OEMs or sending them from the OEMs in different forms and different formats. Now, if you look at the maturity of this exchange process between OEM and supplier for this functional data for different data types, and we look at the maturity of how the process of exchange and the format of that exchange is, then we can see certain differences. Geometrical data is well established in the last decades in terms of process and in the terms of neutral generic standard formats. And this is not so much the case for functional data. Most companies, most mechanical manufacturing companies will know this, that functional data, the process for functional data is by far not as established as that for geometrical data. And the even bigger problem we face is that the format has, there's no standard yet established for functional data. We see it in different forms in the exchange between OEM and suppliers. Excel is commonly used, but we also see, for example, pictures and JPEGs in terms of transferring information on how a curve, for example, is. Then here, we saw that as the need for starting a working group and working on a requirement that suggests how to use a standard data format for functional data exchange. Functional data, again, is usually represented in terms of scalar values or curves or maps. And so Excel is usually used in this case, but we needed something that will fill more requirements. And we wanted a format that supports the exchange process not only from the supplier to the OEM, but also on the requirements side from the OEM to the supplier. And for both parties, we needed to fulfill certain requirements in order to make this a win-win situation, for OEMs and suppliers. So that's the reason and the initiation of the working group FDX. And I would now like to come into some of the concepts that we've established over the recent years. When we started the working group, we looked around of what was a basis we could build on. Directly what we were looking for was not available, but we found something that came relatively close in terms of the base. The ASAM ODS is a standard for measured data or measurement data, and we saw that this was quite well suited for our purposes as a base data model for what we needed and what our requirements were. So we took the ASAM ODS model, but that is a very generic and very basic model and is not very applicable in specific terms. So we looked around and found that the OpenMDM Eclipse working group had done some extensions and some concretizations of the ASAM ODS data model and standard, and we took that as another part of our FDX framework. And found that some of the aspects already needed some extension. So we looked at what was there and then extended some of the aspects in this very application model for our purposes. And finally, we took all this and added even some more features and some more aspects of this information and this data model, and came to the conclusion that certain aspects were easily done and some were more difficult to do, but we added a specific value list, part types and different names and name scenes, and were able to come up with a solution that is proven on industry. The ASAM ODS standard is a proven and valid industry standard, and OpenMDM is also to some extent spread around the industry, and we now come up with something that builds on those two platforms and frameworks, and is now the FDX format which we are proposing here. All this together is the application model for our FDX format. And if you go to the next slide, we used another aspect of the ODS standard, namely the ATFX XML exchange file format, which is also the basis for our exchange file that we're using. So one of the aspects of ATFX exchange file is that it has a complete application model incorporated in every exchange file. So all the information about the model, the data model, is incorporated in every file, and it makes it much easier for certain tools to use this file format and build their application and functions based on what is inside this data file. In the meantime, we had come up with about 500 500 attributes which we found necessary for our requirements. Now, in order to organize these 500 attributes, we come up with certain blocks and categories in order to structure this information. We followed a little bit the workflow that was available and start here with the instance data, which is basically an order. We always start with an order for a certain functional data information. So the turquoise blocks here will have some representing of the metadata, certain attributes that we defined that give information on this block. For example, a measurement order would have information on who is the supplier, who is the OEM, and what is the order number, for example. Now, the next block that we needed was the differentiation between order and delivery. I mentioned before that we wanted to support the process of requirements sent from usually the OEM to the supplier. So that usually represents the order aspect of such an intervention. And then the second aspect is the delivery. So both aspects are being covered here. We have both types. Both blocks can be simultaneously in one file. And we accounted for the different information that goes along with this type of information in terms of different metadata blocks on the order on the one hand, on the very specific component that we're dealing with here. The next block is then a block where the actual information on the functional data is incorporated. And we wanted to be able to distinguish between target data and target values and actual values. Usually most of this information is going to be measured, but we also allow for engineering judgment data, or we allow for simulated data and calculated data. So we wanted to be sure that we were able as an OEM to provide target data, what we expect from a certain component or the properties of a component, and compare that later on to the actual data from, for example, a test rig measurement. So the next block then actually contains a set of very important metadata. On the one hand, some metadata on the data set itself, for example, an ID or something like that. But the main three categories here are the unit under test, which is usually the component that is being tested. And here, certain information for this component will be provided. For example, has it undertaken a certain preload or any other sort of information. Then the next information will be on the test equipment. With what test equipment was this information generated? And finally, the test sequence. Although in what sequence? For example, if you take a suspension spring, you want a translational force applied over certain points or frequency. So you need that sort of information to be transported here. And finally, we come to the last block, which actually then contains the functional content data on the one hand, and on the other hand, we decided we need a category and some information on derived characteristics. Usually these are going to be scalar values, for example, or other curves, which are generated very closely to the generation of this functional data process. So we thought it was important that this data can also be provided in the same file. Now, one question could be, why do we have so much information for just a single or a simple curve? Well, we heard today earlier that you need traceability throughout the whole development process. You need traceability, and here we talk about traceability across companies. So we wanted to make sure that all the relevant information is provided when we receive functional data for the simulation on virtual prototypes. And we can only achieve that if we have this information provided where the source of that information comes from, mainly the suppliers. So we decided we wanted this information all together in one file and being able to transport that. Now, another concept that we came up with is we decided we wanted a container concept for transporting our files. So the ATFX file shown here is what I just showed you. We will have all the functional data and metadata relevant for the case. And we decided, we have not yet implemented this, but we're going to have provided for it to allow for a check seal to give information on the integrity, on the quality of the ATFX file, for example, and make sure that on first sight you'll be able to see if the syntax of the ATX file, for example, is accordingly. Now, and because the ATFX is purely let's say data and numbers driven in most cases, we wanted the possibility to add more attachments to it. If you have a picture, for example, of the test rig setup or the coordination system, we needed the possibility to provide this kind of information as well. And so that we decided to choose a zip container context and format to transport all the information together. Let's go to some more organizational aspects of our working group. As mentioned before, we are a joint working group of the prostep ivip Association as well as the German Association of the Automotive Industry. We've been established first in the VDA in 2015, and we've come together as a joint working group with prostep ivip in 2019. We currently have 5 OEM manufacturers from the automotive industry and about 8 suppliers in our working group. The scope of our work is generally focusing on the business side, so what are our requirements, what are our use cases, but also on some of the technical concepts of how we go about to achieve those requirements. And we are in the process of, no, we're not in the process, we have released the part 1 of our recommendation. It was released in 2018 as a VDA recommendation, and just this week, happily to announce that we've released the prostep ivip recommendation, so that will be available to download on the prostep ivip website. We split the whole information on FDX in different parts to make it easier for the reader to handle this information. We have published and released the first part now in German and English. The part 2 will have more specific information on the data model and on certain concepts of how we implemented them, whereas the first part is more on a generic term, but it gives the context and basic information on FDX. And part 2 will be released by the end of this year. We then have further parts, and we started off with certain specific components, namely the rubber mounts and shock absorbers, and we're going to publish those specific parts and component-specific information in the parts 3.1 and 3.2 also in the next month. You heard the terms workflow forum and implementer forum maybe in one of the previous presentations today. So we consider our current working groups and the terminology of the prostep ivip as a workflow forum, meaning we are dealing with the use cases and our business side requirements. And we have OEMs and suppliers, mainly out of the automotive industry. And we're now going to initiate an implementer forum. That is our intention. And that looks more into the tool vendors and engineering service providers who are dealing with the implementation of FDX in their tools, in existing tools, or come up with new tools to support this format. We have currently one reference implementation from one software company that is available to the member companies of our working group, so that we can pilot FDX within our group. But we're hoping to be able to gain more interested companies from the tool vendor side or from the engineering service provider side. What is outside of the scope of our working group is the data management, the internal data management on the supplier or the OEM side. So this is a part we are not looking into. But as I said, we are good on the way as a workflow forum, and we're now trying to initiate the implementer forum focusing on the implementation of FDX. Coming to the last slide, let's look a little bit on the roadmap that we have in front of us till the end of the year in 2021. Just mentioned, PS prostep ivip recommendation has been released this week. And we started in June using our reference implementation for FDX, the tool side, and we're currently in the process of evaluating that and gating usage and experience with FDX as a format and the tools. We will continue to work on the release of the different parts. We will come up with a slight revision in the next weeks and months. So part 1 will be released as a version 1.1. But our main focus currently is also on releasing those parts which have not yet been released, part 2 and part 3, 1 and 2. So those will be released in the coming months, and we're in the stage of finalizing those. We just wanted to make sure we gained certain experience from the pilot usage of our reference implementation and with FDX as a format before we release these kinds of information. The focus next year will be very much in terms of releasing parts for more components. So currently have an emphasis on chassis components, but we will definitely go look into other parts like powertrain components or other components, and depending also on which companies join us maybe. And as I mentioned before, we're going to focus on the implementer forum, which we're going to start this year. Hopefully in October, we're going to try to do a kickoff. And next year, we want to focus on those engineering tool suppliers, tool providers, and tool vendors to support FDX. So we're going to focus on the implementer forum a lot as well. So that gives a short summary and a short description of FDX as a new format for functional data exchange. I hope I was making it a little interesting for you, and you show interest in joining maybe our group or our implementer forum. And I'm open or happy to take any questions. I think there's a few minutes.
There are a few minutes. Thank you, Dirk. Round of applause for Dirk, ladies and gentlemen. Good morning to everyone out there. Right, so Dirk, thank you so much for the presentation, which was indeed, of course, interesting, especially the roadmap. Thank you for giving us an outlook towards the future. Also, that was very interesting. We did receive a couple of questions. You can see them on your screen right here. Let's take the first one first from 312. We can see at the bottom. Why not adapt Apache Avro for measured data? It is easy to use from all standard data analysis framework.
Sorry, I was reading the top part. Did you read it?
I was reading the one on the bottom that came in first.
Okay, I'm not aware of the Apache Avro. Sorry, we haven't looked into this, if it's a format or a sort of thing. I am not aware of it, and obviously none of our group members was, so we haven't yet looked into this. I don't know if it's too late for it, but we'll look into it now and see if we can make any use of it.
That's perfectly fine. Thank you, Dirk. Moving along, our second question. Thank you for the presentation. First of all, the prostep ivip DDP digital data package working group is investigating 3D PDF as a container for data, human readable information and files, as well as 3D visualization. Why did you choose zip as an archive format?
Well, we're not finalizing that. We wanted something very simple, and at the time we looked at it, I mean, one has to say our working group has started about 5 years ago, so certain aspects might not have been available at that time. The DDP working group, I don't think it exists 5 years already. I've seen the connection to that working group and to that package, and we will look into it because we're not fixed yet, and we're still in the beginning of the process of FDX. So I can just say we will look into it, but at the moment, yeah, we have wanted a very simple context, and we wanted something that's already there, and the zip format is there, it's available, and the DDP package is not yet available, or the format that they're talking about, so we have not yet taken this into account.
But in these terms, you're still open for new opportunities or possibilities
I think
in the
if
future.
it proves that that this type of container is much better suited for our needs, I think we'll definitely could go there. I understand it doesn't make sense to use something that is there and then to try to combine different formats and standards as possible. We'll look into it. We haven't yet gone into that detail.
All right. Thank you for that, Dirk. We have received 2 more questions. Let's take one of them at least. How does traceability to industry standards take a place in the working group, or take place within your working group?
How does traceability to industry standards? I'm not sure I understand what's meant with the question exactly.
I was hoping you would.
Well, traceability is obviously a main issue. I mean, traceability, that's why the reason we put so many attributes and information in this in the FDX format. In terms of traceability to industry standards, I'm not quite sure how that relates to one format, but we're not tracing standards as such. We're trying to define a new standard based on common used standards as ODS, as I mentioned, and we're using the traceability aspect of the process. Yeah, well, that's what I can say. I'm sorry, I don't. I think I fully understand the question.
All right, let's just move on to one last question, and then our time will be up. Arno says, thank you for this great presentation, first of all. How will you delimit FDX data from requirement data exchange functional data? For example, target data are often identical compared to requirement data.
Well, I understand that in terms of requirement management, there's a lot of going on, and certain information is probably processed and transported through requirements standards. We felt that the specifics of details of information that we wanted to convey, and we wanted it in one format, and makes it more automatable in terms. So we wanted that as an entire package in our format. So I don't know if you can delimit it from that. There is a certain overlap. There's always going to be some sort of overlap in certain standards. We try to minimize that, of course, but we felt that we needed this information, the target information, very closely to the actual information, so that we can compare if the actual meets what we set out as a target, and we felt that this was best done in one format.
Thank you, Dirk, very much for clearing that up and specifying, and all the best to you. We look forward to seeing you in May, I hope, next year.
Thank you very much.
Dirk, ladies and gentlemen, once more, thank you.